The oceans and seas encircling Europe are no longer vast empty spaces. Infrastructures for harvesting food, energy and minerals are claiming the ocean waters. From sheltered coastal areas, offshore industries now move into deeper seas. To meet these new challenges, research projects explore the next generation of marine infrastructures.
I believe that support for multi-use platforms in the ocean is going to be something that will be increasingly important as we go forward. Increasingly important as space in the ocean at the coast is going to become more precious, so we need to move into deeper waters. In doing that, I think it is important that that is done sustainably. If we're going to do that sustainably, then we have to look at multi-use of these platforms. Particularly from the point of view, they cost an awful lot of money. So to get a return on the kind of investment that's involved, I think you can't just say that a platform is for one use only.
To improve the use of ocean space, researchers from the European Mermaid Project combine different marine infrastructures into one multi-use area.
Multi-use platforms support a range of different activities, being the production of renewable energy, exploitation of marine and biological resources, water desalination, fish farming, fish processing, and so on. So it is by combining these facilities and these activities in one shared platform that we can reduce the costs.
For every case study, we asked representatives of different organizations and local people to give their opinions about the design and how it should look like in the future. If you are in Spain or if you're in Denmark, the Netherlands or in Italy, it of course differs what people's preferences are for what type of economic activities they want to perform in the area. But also national regulation changes, and the history of the use of the sea and of nature conservation at sea also is different. So yeah, they're very different.
We don't have any these kind of structures in Italy and in the Mediterranean area. So we have more than 100 gas platforms in our area in the Northern Adriatic Sea, so quite a lot. But at the moment we have never developed such a kind of integrated design. So the basic is also, the real challenge is to develop a design that include also the use of renewable resources.
Harvesting energy from the ocean has become ever more important. Offshore renewable energy will play a major role in Europe to achieve the sustainable energy targets.
The potential of wind and waves is well distributed all over Europe. We have very good resources compared to other countries in the world and other regions in the world. But most of the wind energy resources are concentrated in Northern Europe, close to the Baltic area, the North Sea, and around the UK. But there's also some very good resources in the southern countries like the north of Spain and Portugal, with a small spot in the Mediterranean, mostly close to France and to Spain. As with regards wave resources, the best wave resources are located in Ireland, Scotland, and again in the north of Spain and Portugal.
Building far at sea can be very challenging. Developing offshore platforms require innovative technologies and scientific understanding of waves, currents, and the seabed. Ocean scientists and engineers are looking for solutions to protect offshore structures from the harsh conditions at sea.
Some of the engineering difficulties that we have to cope with in the offshore region are the harsh conditions. When we go offshore for placing the wind turbines, we have the high wind potential, and that is what we want. But also, automatically, we will have to cope with the harsh wave conditions. In order to better understand the impact of offshore conditions on the structure, you could measure the conditions offshore. However, this is much too expensive. It is better to conduct scale modeling like you can see here at the Deltaris wave plume. We model on scale an offshore structure, and we generate offshore waves on scale and look at the impact.
Most wave energy generators are still under development, while fixed offshore wind turbines already contribute to the European energy production. A new type of wind turbine is the floating turbine, developed by a European-based energy company.
We have our high wind project, and which we have applied the competence from oil and gas platform to offshore wind. The value of the high wind project has pushed the limitation from water depths to the current water depths like 20, 40 meters to a few hundred meters and even 1,000 meters. With this floating structure with the anchoring to the sea bottom, so in principle there is no limitation for the water depths. This demo project is already in operation for more than 3 years now, and the operation is very successful. It's not only proved the technology feasibility, it's also actually the production factor is very high. It's more than 50%. It's become one of the most productive Siemens wind turbine so far.
They are built for coastal work. They are not built for offshore work.
Collaboration with other industries can lead to the reduction of the operation costs in offshore wind.
This is a large-scale salmon farm off Bergen in western Norway. It's a typical example of a large-scale industrial aquaculture. There's about 4,800 tons of salmon out here right now. If you take an area and use it for aquaculture, you don't necessarily exclude every other activities. Of course, you can't go in and fish between those cages here, but you could place a windmill here. You could have the same area utilized for energy production of renewable, non-polluting energy and aquaculture. Thereby, you reduce the demand for space because two different industries can use the same area. So, in a situation where the accessibility to area is quite central, co-use of area for aquaculture and energy production becomes very interesting.
The ambition of the Mermaid Research Project is not only to combine marine infrastructures into one area, it also examines how to contribute to the increase of marine aquaculture in Europe.
Aquaculture is stagnating, not in Norway. We still open new areas in northern Norway for expansion, but in Europe as a whole, there has been no growth in aquaculture production. And as many know, there's also no growth in the global fisheries, which means that the global demand for seafood has to be met by aquaculture. So how are we going to do this? One of the things we can do through the Mermaid project is to open new areas for aquaculture production, thereby increasing Europe's total production of seafood.
In the European oceans, the offshore wind farms has been under a very huge development during the recent decade, whereas the aquaculture has actually stagnated. And if we look to the rest of the world, it is quite clear that the aquaculture industry is growing very fast. And we actually think that we should try to also develop aquaculture in the same fast way as they are doing it in the rest of the world. Mermaid will contribute to the development by suggesting several possible solutions, or we could say designs, at least 4 different sites in Europe. And the structures can be, you could say, built upon known designs, but it could also be a completely new type of structures. Based on this research and work, we'll be able to produce guidelines that can be used for the development of multi-use offshore platforms. And further, we would like to address the legislation and also the socio-economic and environmental impact of the multi-use offshore platforms.
Scientists are studying 4 test sites in Europe with different environmental characteristics. The Baltic Sea, the Wadden Sea, the Atlantic Ocean, the Mediterranean Sea. At the Baltic site, marine aquaculture has already proven to be a good second function next to wind energy. The Waddensea site is relatively shallow and is characterised by a high nutrient load, therefore it is best suited for aquaculture of seaweed and shellfish. The Atlantic site is a typical deep water site. Facing the Atlantic Ocean, it has a high potential of both wind and wave energy. The Mediterranean site is a sheltered site. A combination of wind and wave energy might be an option, but aquaculture will certainly be a good investment. This research is of interest to stakeholders and end users. It will contribute to the sustainable use of the European marine resources upon which many economic and social activities depend.
So one of the most important legal instruments that Europe has developed to protect the marine environment is the Marine Strategy Framework Directive. And this directive aims to achieve a good environmental status by 2020. And therefore it uses an ecosystem approach, which means that we try to map the ecosystem services the oceans and sea provide. For example, one of these ecosystem services is the fish we harvest from the sea. On the other hand, we also try to assess what impact human activities have on these ecosystem services. So for example, if we build these multi-use offshore platforms, on the one hand we harvest energy from waves, from currents. We also impact the hydrodynamic regime and the sedimentary regime around these structures. So it is important to have an idea about the impact of these multi-use offshore platforms on the environment in order to achieve this good environmental status.
And at the end of the day, we want to identify the design that will enhance, will increase social welfare the most.
So for us, the Mermaid Project and what it's doing is not, as the public might think, about looking for mermaids. It is in fact about ensuring that people are very much focused on the areas that the Commission supports. So renewable energy is very important, climate change, environment, and also from all of the other elements that could be involved in renewable energy. We are investing large amounts of money in the different areas that I talked about, and therefore we think from that point of view the Mermaid Project does an awful lot of really important research that will help us in our policies.